Good afternoon, my fabulous chemistry students. There, I said it. Haha, I said it. Organic video lectures number 2. Today we're going to dig into specifically alkanes. Alkanes are the simple form of hydrocarbon that we could come up with. It's going to be all single bonded. When you're done with today, you're going to be able to draw and be able to name them. Okay, that's today's goal. We're going to devote all of this to alkanes, this whole video. Okay, give a name, all the compounds. Yep. They're the simplest form because it's all double bonded. They are also, all single bonded. Because of that, they are what we call, what is it? Saturated. Yes, saturated. So alkanes. Specifically in table Q, in our reference table, we see alkanes. So whenever I see the word or ending in ane, that's going to tell me that I am single bonded for my carbons, is what we're going to find out. And then the next video, we're going to get into these alkenes and alkynes. We'll put those together, and that's going to tell us double bonds and triple bonds, okay? There we go. Homologous series means a group of related compounds, and they differ by one carbon unit. Okay, so what does that mean? Well, so if I have a C3H8, whoops, that should be a little 8. The homologous series, the next thing is C4H10. That's all. One carbon unit adding on or deleting. I'm part of this homologous series, if you will. There's always 4 bonds or 8 electrons around carbon. Absolutely. A little bit of review, and only 2 around hydrogen. So we got to remember that as far as making these. That's part of the rules. Next piece of reference tables, reference table P. These are going to give me my prefixes for these organics. If I count the number of carbons, if I have 1 carbon, it's going to start with meth. If I have 4 carbons, it's going to start with bute. It's that simple. So this is going to help me name these things. And unfortunately, there's an ine, which is, ooh, this is supposed to be all anes, Mr. Milks, and one snuck in on me. So C3H8, 3 C's is prop, and H8 ane. Okay, it's all single bonds. I don't like that we're actually doing this so early in the notes. I haven't given you any rules yet, but that's all right. I'm going to work my way through it. Propane, prop is 3 carbons. C3. I have a triple bond in my carbon, so let me draw it. 1, 2, 3. Boom, boom. Notice there are 4 bonds around this carbon in the middle. Try and draw it around there like that, bam. But so he's not going to get any hydrogens. He can only make 1 more bond, but this one here can make 3 more bonds. So it's C3H4. And this one here is C4H8. Let me draw it. C4. I have 1, 2, 3, 4, 5, 6, 7, 8. So I need 1, 2, 3. I need a double bond in the middle. Double bond is an ene. I know you don't know that yet. And 4 carbons is a bute. And having a double bond is an ene. Butene. So this is what after these next 2 videos, these are what we're going to do is anes, enes, and ines, and how do we do this? So I'm going to get, why don't you come back and do 4, 5, and 6. 6 you can do here because it's an ane, okay? The enes, I want you to do at the end. How about I just do them now? You do the ane. You do the ane, I'll do these. Pent. Pent is 5 carbons. 1, 2, 3, 4, 5. And it's an ene, but I don't know where the double bond is, right? But there's got to be probably 1 here. So let's say 2 hydrogens gives me 4 total bonds. I have 3, 1, 2, 3 on this carbon, so it only has 1 H. This one has 2. This carbon has 2 bonds, so it needs 2 more. This carbon has 2 bonds, needs 2 more. This last carbon has 1 bond, so it needs 3 more. Each dash line is an H on the outside. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's C5H10. That 10 should be smaller. C6H10, let me do it out. 1, 2, 3, 4, 5, 6. I have 1, 2, wait, do we 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's see. This carbon's going to have one there, one bond there to make this 4 bonds. This one has, the second carbon has 2 bonds, so it needs 2 more. I can't put in any more H's. This one needs a bond here. This one needs a bond there to get it 4. This one needs a bond there. It's going to look like that. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. And so that's going to be called, it's going to be an ene. I have 6 carbons, so it's going to be a hex. And I have 1, 2 double bonds. So it's going to be called, is it carbon 1, 2, so I have a 2, 3, 4, 2, 4 hexadiene. Yeah, tough, right? You're going to learn all the rules and be able to do that, I promise. So there's a little preview of what you're going to be able to do in the next 2 notes. Whew. All right, slow down, Mr. Milks. Can you teach me some rules, please? Okay, yes, I can teach you some rules. Alkanes, saturated aliphatics. The aliphatics are those straight line guys. We use them as fuels like propane, butane, and lighters. They release energy when they're burned, okay? They all end in ane, which is a saturated single bonded hydrocarbon. We just talked about that last slide, okay? General formula is this, CnH2n plus 2, okay? That's a general formula. So what does that mean? Well, the N is a variable. So in this case, pentane, I have 5 carbons. I looked that up. Pent is 5. Ane is single bonded. The N equals 5, right? So if I plug that back in, that'd be C5. And then the H, it's going to be 2 times 5, which is 10, plus 2 is 12. And then here's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's what it looks like. So here's the structural formula for pentane. And here is its molecular formula. And here it is done out for you already. You plug in the 5 for the N because that's how many carbons there are. Straight chain alkanes are what we call normal alkanes. You're going to see that there's a few different ways I can write them. This particular shape here, and let me redraw this in red. What this is some real shorthand, okay? This is some real shorthand. I don't know that I want you to ever draw it like this. I will get to where you can call it shorthand and not draw all of this. I will get you there, but this shorthand is a little too short. What this shorthand is saying is there's a C here, a C here, a C here, and a C here, and it's saturated because I don't have any doubles. Okay, so it's real big time shorthand. But they're both the same thing, butane. But is 4 carbons. Ane means single bonded. Single bonded means everywhere there can be a hydrogen, there is. Okay. Branched alkanes. Now I need to be able to tell you if there's something coming off of this chain, if you will. So there's some rules. Okay. A branched means it's not a straight line or a continuous chain. Okay. And how can you tell if it's branched? Well, you can't run your finger down along the carbons in one sweep. So then it's a chain. So here, let me tell you what I mean by that. So if I connect these carbons, 1, 2, 3, there's my branch. Okay. There's another way to do it. Let's do it. As long as I'm not picking up the pencil, it counts. So the rule is that we follow is I make the longest chain I can. That is also the chain, and then this is the branch. Okay. So it doesn't matter how I name it. I'm going to come up with a naming system that gives me this every time, and we're going to be good. Okay, and what I do is I put a number in front of where that branch is. That tells me which carbon is being, which carbon has the branch on it. Okay. Moving on. Some molecules may appear to be branched, but they are not. And here's an example. And let me show you why I know it's not branched. So if I take my pen and I put it down on carbon, and don't take it off, can I connect all the carbons? 1, 2, 3, 4, 5. So that is the same thing as this. 1, 2, 3, 4, 5. The thing is just bent. And then here's some shorthand. There's a hydrogen on every dash. We'll get there too. Okay. So 1, 2, 3, 4, 5 carbons is pent, single bonded ane, pentane. That's how we get it. That's the rules. That's simple. Naming branched alkanes. Locate the longest possible carbon chain. That's what I just showed you how to do, right? Name the branches first if I can. Prefix based on the number of carbons in the table P, of course. Suffix will end in "ill." Branches are named separately unless there are two of them that is the same. Then I use a die in front, which you saw me do on the very first page. Okay. The parent chain is stated last in the name, and that's the number of carbons in the parent chain. Here is an example, and let me walk you through before we get the name. First step, 1, 2, 3, 4, 5, 6, 7 carbons. 7 is sept, I believe. Sept. And I have a chain, which is a single carbon. 1 carbon is a meth, so that's going to be a methyl. And the YL lets me know that is the side chain. And then my 1, 2, 3, 4, 5, 6, 7 carbons are all single bonded. And it's not sept, is it? It's hept. Come on, Mr. Milks. Have you ever taken chemistry before, Mr. Milks? Heptane. Please tell me I'm right, that I got it right. The other thing I need to know, though, where is that methyl? Is the methyl on this carbon, or is it on this carbon? I need to be able to tell me, so there's a roadmap. So here's how I do it. The rule is, whether it's stated above or not, this is my rule that I always learned. The methyl has to be on the lowest number carbon it could be. So if I started naming here, it'd be 1, 2, 3, 4, 5, 6, 7. And is 6 the lowest number carbon it could be? Well, actually, it's not. Because what if I just started on the other side? What if I did 1, 2, 3, 4, 5, 6, 7? Now it would be on carbon number 2. And that's what I want to use. I want to use this lowest number carbon possible. So that's the rule. So it's going to be 2-methyl heptane. Let's see if I got the hep right, because I don't even have reference tables in front of me. Yeah, 2-methyl heptane. Got it. So now the naming works as a map. I need to be able to go backwards and forwards with these things. So here is the shorthand that I do not like and I do not want to see you guys use, but I'm going to go through it now. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 has got to be something like nano. 9 is nan. I may look this one up because I'm not getting this one wrong. Yeah, 9 is non. I was really close. It's non. So 9 carbons is a non. And they are all single bonded, so it's nonane. See how we do that? But I have a side chain at 3, 7, 4, and 3. Now notice, if I were to go backwards, I'd have 1, 2, 3, which I have 4, 5, 6, 7, 8, 9. What I have in reality in the red is 3, 4, 7, and that is lower than if I counted the other way. The other way would be 3, 6, 7, and 3, 4, 7 is smaller. The total number is smaller, so that's why I go that way. That's the rule. Let me get rid of these greens because we don't need them now. On 3, 4, and 7, I have a single branched methyl, so it's going to be 3, 4, 7. Trimethyl. I have 3 of them. Trimethyl nonane. See if I got it right. 3. Yeah, see, I don't like that. See, it's 3-ethyl. Oh, see, I made a mistake. See, I didn't catch it. Here, let me explain why I made a mistake. I just didn't see it because I went too fast. This one's got a carbon and a carbon. That's even more different than 1 carbon and 1 carbon. So there's my ethyl. So let me go back through. 3-ethyl, 4,7 dimethyl nonane. Okay, and that's all right. Good, I got it right. Okay, phew. scaring me, Mr. Milks. Just went too fast. Just went too fast. See if I can do this one. All right, I got. Notice how I see these here and here. I want to start counting on this side so they're in the lowest numbers. If I start over here, they're going to be higher. So I have 1, 2, 3, 4, 5, 6, 7, 8 carbons. 8 carbons, look on my handy dandy reference table, is an oct. They are single bonded, so it's an ane. And then at 1, 2, 3, and 4, I have a 1 carbon, which is methyl. So I have a 3, 4, because I have 2 of them, it's going to be called dimethyl octane. No period. Dimethyl octane. Okay? Well, these look complicated. I'm going to give you number 4 to do. I'm going to give you number 4 to do because the chain is there for you. 1, 2, 3, 4, 5, 6, 7 is the longest chain I can make. If I were to say it this way, 1, 2, 3, 4, 5, 6, 7. Okay, I could make that chain, which is also 7. If I were to go this way, I'll change colors. 1, 2, 3, 4, 5, 6, 7. I've also only gotten 7. So it's going to be 7. Either way, the names is the way we name it, it's going to come out properly. So I'm going to let you try that. Starting with this one here, if you can see it in your notes, this one's 2, this one's 3, 4, 5, 6, 7, because that's numbered like that. I want you to name it that way. I am going to look into this example 5 because this looks scary, and I'm going to do this and hopefully not embarrass myself. Okay. Longest possible chain. Okay, well, I think I'm going to start here. I got 1, 2, 3, 4, 5, 6, 7, 8. That's 8. I don't think I can come up with a better 8, higher 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I can do that. So I'm going to do that. I'm going to call this 1, this 2, this 3, 4, 5, 6, 7, 8. 8 is oct. All single bonded I see, so it's ane. Then if I start at 1, on the third carbon, I have a 2, which is an ethyl. 2 carbons is F. So that this here is an ethyl. On the fourth carbon, I have an ethyl. On the fourth carbon, I also have this methyl. And I'm good. So I have a, now we just got to be able to name it. I have a 2,4 diethyl 4-methyl octane. It's a lot to it. I don't think we're going to have quite so many crazy complicated ones, I think, on the test. Remind me to tell Monaco not to put any of that crazy on the test. Let's see if Mr. Mooks can get this one right. The answer's on the board somewhere. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can I get higher than 10? If I start here on the left, I go 1, 2, 3, 4, 5, 6, 7, 8. That's definitely not higher than 10. And I'm not going to play this business where I go up and around, but let me try it in a different color. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, that doesn't get me anywhere as far as the number, so I'm going to go with the blue. And what I'm going to do, though, is instead of starting here, because that if I start on the left, it'd be 1, 2, 3, 4, 5 before I got to any side chains, if you will. Let me start at the top up here. 1, 2, 3, 4, and I get a side chain, so that's what I'm going to do. I'm going to start at the top up here and call this my carbon number 1. We'll change colors. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 carbons. That's a deca. They are all single bonded, so it's a decane. On the fourth carbon, I have a methyl, a 1 carbon. On the fifth carbon, I have a 1 carbon. That's a methyl. And on the sixth carbon, I have a 2 carbon chain, which is an ethyl. Okay, so I have a 4,5 dimethyl. 4,5 dimethyl 6-ethyl. 6-ethyl decane. Okay, let's see if I got it right. You think I got it right? Let's see if I got it right. Oh, they did the 6-ethyl first. The map is still correct. The reason why they named it this way is that ethyl is more complex than a methyl, I guess. I'm going to take both answers. 4,5-dimethyl 6-ethyl decane. But otherwise, I got the numbers right, and more importantly, the number and the side chain and the numbers in the side chains are correct so that I can redraw it. Either way I write it, I'm going to draw the exact same thing. That's the point of how we do this. So those are pretty complicated. This is pretty long. Yes, I know. But now you can do parts of page 1, 2, and 3 in the practice packet. Still no quiz. And now I basically understand how to draw and write alkanes. And the way this naming process works, I can go forwards and backwards. You give me the structure or the formula, I can draw it. You give me the drawing, I can give you the formula. Either way. Oof, sorry this one was so long, guys, but this is the backbone of the entire unit. We need to be able to get this stuff straight, and from here it's just going to get a little bit more complicated. Good luck. See you in class.